Okay, today students, our learning objective is to use inequalities in triangles. And we're going to start with this little activity up here. We're going to need three colors today, but right here we're going to use two of them. You're going to need a red, blue, and another color. I'm going to choose to use red, blue, and green today. Okay, so color the largest angle and the longest side red. Looking at this, you can just tell what is the longest. So here, this one, there's your longest side. So I'm just going to highlight that in red. And then this guy right here is your largest angle. So I'm just going to shade this angle right here, from here to here. That's in red. And then it says color the smallest angle and the shortest side in blue. That's kind of difficult to tell which angle, so you can get a protractor out. And I got a protractor out and I found that this guy over here was actually smaller. Okay, so this guy right here, that's the angle, and it would be this side. Okay, so what do you notice? Well, what you should notice is that the smallest side is going to be across from the smallest angle. So let's write that down. The smallest side is across or opposite the smallest angle, and the largest angle is across or opposite from the longest side. Okay, so here, notice how this one doesn't have a special name, so if we were to use this one in a proof, we would actually have to write the whole thing out. So this theorem says that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, so it's kind of what we were talking about up here, but let's go ahead and look at this picture. We clearly know that AB is the length of 8 and BC, which is the length of 5. So we can definitely tell that BC is going to be shorter, and I'm going to color it in blue since we colored smallest up here in blue, so that's going to be shorter than this one here. Now I'm not saying that that's the longest side and that's the shortest side, I'm just saying that this one's bigger than this one. So let's write that out. Here I'm going to have AB, and remember that AB, we're talking about a number, so we don't use segment notation. So AB is greater than BC. I'm just going to highlight those. So AB was the red one, BC is the blue one. Okay, so if that's true, then we know that the angle's opposite, one's bigger than the other. So here it's going to be the measure of angle C will be bigger than the measure of angle A. So that's this guy right here in red, and I'll just highlight this one. And that's this guy right here in blue, this angle right here. Okay, so if red is greater than blue, then red is greater than blue. Alright, the next one. Again, this doesn't have a special name, so if we were to use this in a proof, we'd have to write the whole thing out. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller side. Okay. So here, this time we're talking about the angle. So it's kind of like the converse. It's going backwards. So here, I know that this angle right here is definitely bigger than the other one. Since we use blue for smaller and red for larger, I'm going to just shade these in. Blue and red. And what that should tell us is something about these sides over here. So opposite, since this is red, I'm going to color this one blue. And this one, I'm sorry, I said blue. Since this one's red, I'm going to color this red. And since this is blue, I'm going to color this one blue. Alright, so now let's fill in what we know. If the measure of angle A is greater than the measure of angle C, if the red one is larger than the blue one, the red angle's larger than the blue angle, then those sides opposite. That means the red side, BC, will be larger than the blue side, which is AB. So the red side and the blue side. Now you should notice here that the next three theorems have special names, so you can just write the name of the theorem as opposed to writing it all out, which makes it very helpful. Okay, so here's the first one. It says that the sum, and remember sum is when we're adding things together, it's an addition problem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so on this one, I'm talking about all three sides. So I'm going to use my red, my blue, but I'm also going to use a different color, green. This one looks like it's the shorter one, so I'm going to have that one in blue. This one looks bigger than this one, so I'm going to color this one in red. And then this one is going to be green. Okay. Well, what we know is that if we take the green one and the blue one and we add them together, so AB, notice without segment notation, plus BC, it has to be bigger. When we add those two together, it has to give an amount larger than AC. So in other words, green plus blue must be larger than red. Okay, now, again, if we go back and we choose blue plus red, so BC plus AC, that's going to have to be larger than AB. So in other words, if the blue one plus the red one is added together, it's got to be larger, gives me a larger amount than the green one. Okay, and then the last combination, we've added the blue and the green here. We've added the blue and the red here. So now we need to add the green and the red. So AB plus AC, when we add those together, it has to be larger than the third side, which is BC. So that means that the green plus the red must be larger than the blue. Okay, so there's all three combinations, and when you're testing to see if three sides, the given three sides, can make a triangle, this is what you're going to use. Alright, the next one is the hinge theorem. You can think of a hinge as like opening a door. The wider the opening, the wider the door is open, the wider the hinge is open, the wider the space to come through the door is going to be open. Alright, so here it says if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is greater than the third side of the second triangle. Okay, so, alright, let's take a look at what we have. Here I've got single hash marks. So that means if VX, that segment right there, is going to be congruent to RT. Then we look at the second hash mark. VW is congruent to RS. And we know that one angle is bigger than the other. So here, the measure of angle V is going to be larger than the measure of angle R. What do we know about this third side right here? Okay, so the side opposite the larger angle is going to be larger. So here, XW is going to be larger than TS. And you don't need to put segment notation here, because when you're using an equal sign, a greater than or less than sign, you're talking about numbers, so you don't use the segment notation. When you're using the congruent symbol, you must use segment notation. Okay, now the converse of the hinge theorem is going to go backwards. So here, if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is greater than the third side of the second, then the included angle of the first triangle is greater than the included angle of the second triangle. Okay, so here you've got some conditions to meet first. We have if two sides are congruent, so CB is congruent to FE, and CA is congruent to FD, which it shows here in our diagram. And we know that this third side right here happens to be this one here, AB, you see without segment notation, is larger than DE. Then what do we know? Well, then we know the angle. So we know that this angle right here is going to be bigger than this angle over here. Okay, so that's going to be the measure of angle C is going to be larger than the measure of angle F. Okay, and that's all of your theorems for today. Let's practice a few of these problems. Okay, list the sides and the angles of the triangle in order from smallest to largest. To do that, I'm going to draw a chart. This is my size. They want small to large, so that's going to be small, then medium, and then large. Here I'm going to list the sides and the angles. Okay, so list is not a chart, but I'm going to use this chart to help me organize my data. Okay, so before I was using red, blue, and green, so I'm going to continue that. If I look at these three angles, the three angles, I see that this guy right here is the smallest, so that's going to be in blue. And that means the side opposite that is in blue. Then the one that's in the middle, the medium, I'm going to have that one in green. The side opposite that will be in green. And then the largest one will be in red. And the side opposite that will be in red. Okay, so large is going to be red, small is going to be blue, and medium is going to be green. Okay, so now that I have my chart set up, I can list all the sides. Okay, so small, blue, the blue side is going to be AC, and the angle is going to be angle B, but remember, if we're going to use three letters, that's going to be ABC. Angle ABC, where B is in the middle. The green one, that's going to be AB, side AB, and again, C is in the middle, so that's going to be BCA, where angle C is in the middle. And then red, that's going to be side BC, and that's going to be angle A, but if we're going to use three letters, we have to put A in the middle, so that's going to be BAC, where A is in the middle. Okay, so now if I'm going to list, that means I'm just going to write a string of numbers. So here, list the sides. Sides would be AC, comma, AB, comma, BC. That's in order from least to greatest. Angles, that's going to be angle ABC, comma, angle BCA, comma, angle BAC. And there's my answer right there. And this just helps me get them in order. Okay, next. In the next one, I'm going to use the same trick, but there's this extra step that I have to do. And remember, not all diagrams are going to be drawn to scale. So sometimes, if you're looking at this, you're probably thinking, that's the smallest side, that's the medium side, and that's the large side. But you have to have proof. So you actually have to use your triangle sum theorem in order to figure out the missing angle. Remember that all three of these add up to be 180 degrees. So you've got this angle M, so the measure of angle M plus this one here, which is 127, plus this one here, which is 29, they have to all add up to be 180 degrees. So you have to figure out, use your algebra skills to figure out what is the measure of angle B. And when you plug that into your calculator, you will discover that the measure, I keep saying B, but the measure of angle M is equal to, let's see, 127 plus 29, that gives me 156, 180, take away 156, that gives me 24 degrees. And 24 degrees would be this guy right here, and he's clearly the smallest angle. So remember, not all triangles are drawn to scale. So you have to test it. So if blue is going to represent my small like it did up here, then that means this guy right here is the small, so this would be the smallest side, opposite. Using color in this situation helps because then you don't get it confused and just take a look at it and write it down by how it looks or how it appears to be. Okay, so now if you want to use your chart again, you can, or you can just look up here and write small, medium, and large. Again, this is from smallest to largest. So if I'm going to do my sides, I'm going to list the blue one, then the green one, then the red one. So blue is going to be NP, comma. The green one is going to be MN, comma. And then the red one's going to be MP. Right, and then the angles, using the same trick again, the small, medium, and large. So small angle, that's the M, so that's going to be NMP. Angle NMP, where M is in the middle, because M is the blue one. Then next one, green, that's going to be where P is in the middle. So angle NPM, we want P in the middle. And then the last one is going to be angle MNP. Okay, and there's my answer. And I used the same strategy up here, I just didn't build a table this time. Okay, the next one. Not every group of 3 segments can be used to form a triangle. Is it possible to form a triangle given the following side lengths? Let's take a look. Okay, so here, let's say that we're trying to build a tent, and we're given a base of 5 feet long. So each base is 5. And then we're going to use poles. We're given these poles, and they're various lengths, and we're going to try to build a tent out of it. Well, if this is a pole and this is a pole, when they start to go towards each other, are they actually going to stop and actually give us a tent to where we can get inside? This one's going to come this way, and this one's going to come this way, and they're going to meet right here. This is going to be 3. There's your 3 feet pole, and there's your 2 feet pole. And so they're just going to lay right up on top of the base. So the answer here is no. And the reason why has to do with the theorem that we just learned called the triangle inequality theorem. This guy right here, remember the two sides have to add up to be bigger than the third side. So here, if we add these two sides up, we find that 3 plus 2 equals 5, and that is definitely not greater than 5. It is equal to 5. Okay, so this one over here, let's take a look at this one. Will this situation work? A 2-foot pole and a 2-foot pole, if I put them on the ends, am I going to be able to make a tent? The answer is no, because when this comes down and this one comes down, there's going to be, from here to here is 2, and then from here to here is 2. What's going to happen? There's going to be a gap in the middle. So the answer is no. And the reason why is because 2 plus 2 equals 4, which is definitely not greater than 5. So it fails because of the triangle inequality theorem. Okay, let's take a look at this one. This one, we start off with 4 and 2. Well, clearly, 4 plus 2, which equals 6, that is greater than 5. So that works. So now we have to check all the other situations. Number 2. What about 5 and 2? 5 plus 2, what does that equal? 7. Is 7 greater than that third side? Yes. And then check the next group. Here we've got 4 plus 5. We know that's equal to 9. Is that greater than 2? Yes. So since it's all three situations are yes, then we know that yes, this will make a triangle. Okay, and that's it for today, folks. That was our lesson on inequalities of triangles.